All right, for the last part of the lesson, we're going to do some examples that are a little bit more complicated. You'll see here in this one, you have two trig functions being evaluated simultaneously. Okay, so I want to know what is sine inverse of sine of pi over 3. Okay, so whenever this is presented to you where you have the inverse of a trig or a trig of an inverse, something like that, okay, you want to work from the inside out. So this is what I need to take care of first. Now, because I want to eventually evaluate the inverse of this, the key thing that I have to keep in mind here is this allowed in the region for sine inverse? Okay, so remember that sine inverse is defined from negative pi over 2 to pi over 2. So does pi over 3 fit in there? Yes, it does. Okay, so I can proceed. So what I would need to do first is figure out what this value is. So this says sine of pi over 3. So what that's asking me for is the trig value. Okay, so what is sine of pi over 3? Sine of pi over 3 is going to be root 3 over 2. Okay, so now this all gets replaced with root 3 over 2. And now I want to evaluate this. This says sine inverse of root 3 over 2. So this is asking me what angle, okay, has that sine value. And the answer is pi over 3. Sine of pi over 3 equals root 3 over 2. Now, if you notice that my answer ended up being the angle that was in the problem, here's why. Because I took sine inverse of sine. Okay, these are inverse functions, therefore they're inverse operations, and it's like they cancel each other out. So if I take sine inverse of sine, or I take sine of sine inverse, those are going to cancel each other out as long as, this is the key, as long as this angle is allowed in the region. Okay, if that angle is not allowed in the region, then that goes a little bit differently, and here's what that looks like. Okay, so here's an example. Sine inverse of sine of 2 pi over 3. Okay, so it looks a lot like the last problem that I just did, except you'll notice that this angle is different. Okay, so again, what I need to start is with the inside. I need to make sure, is this angle allowed in the region? Okay, so the region for sine inverse is only the right side of the unit circle. 2 pi over 3 is over here, so this angle is not allowed. Okay, which means that I have to evaluate it the way that I did the other one. So I have to work from the inside out. So first I need to figure out what that is. So sine of 2 pi over 3, okay, all students, sine's positive over here. So this is still going to be a positive root 3 over 2, okay? But now when I do this part and I say now what angle has a sine value, that is root 3 over 2. I have to find the one that's in this side of the unit circle, which is going to be pi over 3, okay, this guy over here in the first quadrant. All right, so you have to check that angle, okay? If the angle is allowed, then essentially these two things, sine inverse and sine, are canceling each other out. But if this angle is not allowed, I have to evaluate that first, then I take the inverse and I find the angle that's allowed in the region for sine inverse. All right, so here's our next one, cosine inverse of cosine of 4 pi over 3. Okay, so again, if I see that cosine inverse and that cosine together, these two functions could potentially cancel each other out if this angle is allowed in the region for cosine inverse. So that's the first thing that I need to check. Is this allowed? Okay, so remember that cosine inverse is only allowed from 0 to pi. Okay, he's the special one. So 4 pi over 3, 4 over 3, this fraction is greater than 1, which means I would be down here, okay, in this quadrant. So that is not allowed. Okay, so I have to evaluate this first. So cosine inverse of cosine of 4 pi over 3. All students take, okay, it's going to be negative. Cosine of pi over 3 is going to be 1/2. Okay, so now I have cosine inverse of negative 1/2, and now I need to figure out what angle in this allowed region has a cosine value of negative 1/2. Well, here cosine would be positive, so it has to be over here. It's got to be a multiple of pi over 3, so now my answer here is going to be 2 pi over 3. All right, what if we have one that looks like this? Tangent of sine inverse of root 2 over 2. Wow, my phone just vibrated a lot. Okay, So tangent of sine inverse of root 2 over 2. Now notice here that the inverse function is not on the outside like the other examples I've done so far. The regular function's on the outside. So here, again, I still have to work backwards. Okay, so this right here is asking me for an angle, not a trig value this time, an angle because this is sine inverse. So I need to figure out what angle has a sine value of root 2 over 2. Remember, that guy is our favorite. That is pi over 4. Pi over 4 is in the allowed region for tangent inverse. Remember, tangent and sine use this side of the unit circle. That is a positive root 2 over 2, so it has to be up here in the first quadrant. Okay, and then now I ask you what is tangent of pi over 4? Well, remember, tangent's the slope, so I'm asking you what's the slope of that line, and that's that good old easy one. That is 1. Okay, 2 more examples. So here we have sine of tangent inverse of 2. Okay, so again, we're going to work our way out, especially because these are not the same function, okay, inside out. So tangent inverse of 2. So remember, what I'm asking for here is an angle. What angle has a tangent value of 2? Well, no angle that I've made you memorize, okay? Tangent of pi over 4 is 1. The other ones are 0 or undefined. So, and then root 3 over 3 or root 3. So none of those are 2. So how do I figure this out? Well, in order to do this, I have to actually draw a triangle. Okay, so what I have to do is I'm going to draw a triangle in the coordinate plane, which kind of goes back to one of the first lessons that I recorded for you guys. And I have to think about where is tangent inverse defined. So tangent inverse is defined here or here. Up here, it's positive. Down here, it's negative. This is a positive 2, so that means that my triangle is going to be up here in quadrant 1. Okay, now, if you remember, tangent, remember, is TOA. So tangent is opposite over adjacent. Okay, so if I write this as a fraction, this is 2 over 1. Okay, here's my angle, theta. I don't know what it is, but I know that the opposite side is 2 and the adjacent side is 1. So in order for me to find sine of this angle, I need to know the hypotenuse because sine is opposite over hypotenuse. And if you look here, we're dealing with a right triangle. I know 2 of the sides. I need the third, so I use Pythag. So a squared plus b squared equals c squared. So this is a, this is b, c is always the hypotenuse. 1 squared plus 2 squared equals c. 1 plus 4 equals c squared. 5 equals c squared. Take the square root. And c is equal to the square root of 5. So this is going to be the square root of 5. Okay. So all of this right here went into figuring out that triangle. Okay, so because this value was not a value that I have memorized, it was not a tangent value for one of those special angles that we talked about in the unit circle. Okay, what I have to do is I have to take that and I have to create a right triangle. Think about what the ratio is. Okay, write that number as a fraction if it's not already given to you that way. And then use Pythag to find the missing side. Now I want to know what is sine of that. Well, sine is opposite over hypotenuse. So sine of tangent inverse of 2 is going to be 2 over the square root of 5, which we know we're not allowed to leave. So we rationalize, and we get 2 root 5 over 5. So that would be my final answer. All right, last one. Okay, so here we have cotangent, COT is cotangent, of cosine inverse of negative 1/3. Okay, so again, right here, we'd be asking for an angle. What angle has a cosine value of negative 1/3? None of the ones that we have memorized. Cosine can be root 2 over 2, root 3 over 2, 1/2, 0, negative 1, but it cannot be negative 1/3 for anything that we've memorized. So this, again, gets interpreted into a triangle. Okay, let me redraw that real quick. Sorry, I realized I need the other quadrant. Okay, so cosine inverse only exists in quadrant 1 and quadrant 2 because it only exists from 0 to pi. Okay, this value is negative. Everything's positive in this quadrant, so that means that my triangle has to be in this quadrant. Okay, now cosine is defined as adjacent over hypotenuse. So if this is my angle, adjacent here is going to be negative 1. Hypotenuse is going to be 3. Okay, so I label my sides of my triangle that way. Now I need to use Pythag to find that missing side. So we're going to have a squared plus b squared equals c squared. A squared can be negative 1. That's fine. B squared is what we're looking for here because c is always the hypotenuse. So 1 plus b squared equals 9. Subtract 1 from both sides, we get 8. So b is going to be equal to the square root of 8. We don't want to leave our answer like that because there's a perfect square in there. So we know that 8 is the same thing as the square root of 4 times 2. The square root of 4 is 2, so the 2 is going to come on the outside. So b is actually equal to 2 root 2. Okay, so this side of my triangle is going to be 2 root 2. Now that I have that, I want cotangent. So cotangent is the reciprocal of tangent. Tangent is usually opposite over adjacent. So cotangent is going to be adjacent over opposite. Okay, so if I'm looking at my angle here, here's the adjacent, here's the opposite, and I want this over this. So cotangent of cosine inverse of -1/3 is going to be -1 over 2 root 2. Now remember that we cannot keep the radical in the denominator, so we have to rationalize. So we're going to multiply just by the radical. You don't need to multiply by the 2 as well. So -√2 over that 2, this is that 2 right there. Root 2 times root 2 is 2. So this is going to become -√2 over 4. That's your answer.